One final note to finish up chapter 3, this is the last video, I've been at this all afternoon, is that when we're looking at this three-dimensional particle in a box, the particle in a cube, we're going to have cases where we have what are known as degenerate states. I don't know why we use this word in physical chemistry and quantum mechanics, but we do. Degenerate here does not mean the usual English sense of something that's depraved or bad. Degenerate here means a degenerate state is two states that have identical energies. Two or more states. And so you've come across degenerate states before. For example, the three different p orbitals, px, py, and pz, those are three different energy levels, but they all have the same energy, right? There's no difference between an x, y, and z orbital in terms of their energies. So those are an example of degenerate states. If we have a cube where all of our lengths are equal, a, b, and c, we end up with degenerate states inside of our particle in a cube. So if we go back to our energy equation, which I conveniently still have up here, right? If a, b, and c are all the same, we can consider cases where we have, say, nx is equal to 1, and y is equal to 2, and z is equal to 1. And if we consider these two other cases, right, 2, 1, 1, and 1, 1, 2, these are all different states, but they're all going to have equal energies. And so we would say that this, the particular energy that goes with this, the energy of the 112 or 211 or 121 state, this would be a triply degenerate state, meaning there are three different combinations of quantum numbers that get us to the same total energy. And so, we can think of what are other possible degenerate states. And, anything where the sum of the squares of these quantum numbers ends up being the same will give you identical energies. And so this idea of degenerate state shows up again and again in quantum mechanics, especially in cases where you have symmetries, much like the cube we're talking about where A, B, and C are the same, or like the hydrogen atom. We see that there are multiple degenerate states there, as I mentioned, the p orbitals, for example. And so this idea of degenerate states is again also going to show up multiple times as we move into looking at other systems.